Okay, so if you were away on Tuesday, this is a quick crash course. Okay, so on Tuesday I started by saying the following: if I say I'm not going to tell you what that means, so that's the first thing. When I write these symbols together, Y, that little fish in the middle, and X on the right, can you complete the sentence? Okay, great.
It's again annoying having to write like how are you writing that?
What do you mean?
Like show me. Oh, you're using a pen, okay. So how do you match it up to what you see on the screen?
I have to look at the screen.
Oh.
Yeah.
And do you see where the pen, like the dot is?
Do you see the cursor? The
Yeah.
the thing?
Oh, that's
Yeah.
cute.
Yeah. Okay. All right. So this is a good start. Y is proportional to X, and then you'll need to look back in your notes. I described two ways to think of proportionality here. So I gave one explanation involving a graph, and I gave one explanation involving an equation. So flip back in your notes if you took them on Tuesday. Let's start with the picture. If I draw a graph between y and x, what should it look like?
Straight line going through 0, 0.
Beautiful. Okay? So if I have x and y like this, then if I draw a graph, it is a straight line through the origin. The origin has coordinates 0, 0. Is that okay?
Yes.
All right. That was the picture. Then the second explanation of this involved an equation. What was that? What was all that about?
Oh, the y is
Very good. We can write y equals kx. Remember that when I write two letters like that, I'm saying I'm multiplying the two letters together. So that means k times x. And we give a name to the letter k. K is called the constant of proportionality. And by convention, we assume that k is positive. I didn't draw enough attention to this last lesson, so we're assuming that the gradient is positive here. Okay, so k is also the gradient on the left. Okay, now just for the benefit of those of you who were away, or maybe you've forgotten what we did last lesson, I'll do two examples. So we're still not covering any new content yet. So the first example is, and you don't have to write this down unless you want to, write down an equation relating the two quantities involving a constant of proportionality. So what do I mean? That's right. Based on this second explanation here. Yeah, yeah, yeah. I'll give you a few seconds.
Can you like switch it on Teams?
Yep. So the one from last lesson should already be on Teams, I think. If I forget, just remind me. Yeah. I'm going to have to cut this topic short because we're running out of time. So we'll just do probably A to D. We'll leave out E, and then we'll do the exam in week 7. Thanks. Okay, so y equals kx, yeah? All right, let's do a different one. I'm going to think of a chemistry example. Hmm. That's right.
Wait, I'm confused. Where did you get K from? Is that what the fish thing is?
That's right.
Okay.
Okay. That yeah. It's not actually called the fish thing. It's I'm just using that because you know what I mean, yeah. That's the symbol in the middle. All right. Let's do another one. Um, okay, this is a physics one. Yep. And we went one step further. We started doing other things to the thing on the right. So that can involve indices, square roots, but it's exactly the same idea. That's right. K times the thing on the right. Okay. All right. Is that okay? Because if we're not okay with this, the rest of the topic won't make any sense. Because we're going to start doing different things to the thing on the right. All right, now you can start taking some notes for the new part. So I should say before that, this was direct proportionality. That was 9A. And today, we are looking at something called inverse proportionality. That's your heading. And this is exercise 9B. So we're going to do exactly the same thing we did on the last page. This time, the equations are going to look a little bit different. And they're going to involve fractions. So don't panic. I'll explain what's going on. Oops. Let's do another one. Let's go with, we'll do a physics example again as well. So as I said on Tuesday, proportionality is really most useful if you're doing a science subject, and I'm thinking in particular physics and chemistry. You see these kinds of relationships all the time. If you're outside those subjects, the most useful one is direct proportionality, which we did on Tuesday and just on the last page. I need to give you a picture soon. So, I'm going to draw this in orange because I don't want you to write it. It's just to explain. So, before we said y was proportional to x, what equation did I need to write down? Y equals kx. Okay. Now, based on that, what do you think you would write down here? So something like this, right? Don't write it though. Is this what you mean, Ben? Yeah. Okay. So that's fine. Now, is there a simpler way to write k times 1 on x? Ash?
Would it be K over X?
Yes. So I pop into a year 10 class once a week. So you do study this thing called algebraic fractions. I don't really have time to go over that this year. But if you didn't know this, maybe just copy that down as well. I'll draw something on the board.
What, the K times 1 over X?
Yeah. So what's happening is we're saying y equals k times 1 of x. That's just the definition. Now, k is the same as k divided by 1. If you divide by 1, nothing changes. And when you multiply two fractions, you multiply the numerators together, and you multiply the denominators together, and that leaves you with k on x. And this is kind of the simplest way to write this, and this is the way that we're going to use it. Okay? So I want you to write it like this. This is the explanation. If you can follow the explanation, great. If you're not following this, this is this. All right, Bruce, what do you reckon I'm going to write for this second one here? Great. Let's go with Lexi. I know you were away on Tuesday. What do you reckon for this one? Great. That's it. I'll put in another one. Is there another law I can think of? Yeah, we can do a square root. No, like just a regular one. Have you learned the ideal gas law in chemistry? PV equals nRT. Sorry, it's been a long time since I've been at school. Okay. Beck, what do you think goes here? Speak up. That's it. And Ben, what do you think goes here? Yeah. So notice that stays the same, and I just introduce the constant k. Okay. All right. I know it's a bit symbolic at the moment. There's no numbers at the moment, and you're not maybe you're not used to that. I'm going to do one with numbers next. But before I move on, does anyone want to ask me a question about this? Yes. What's up, Maddie?
The one is represented in K, is that right?
So
You just change them to one.
yeah, well,
Place the one in K.
so you can kind of think of it like that.
Yeah.
actually think of it the other way around. These four equations, they look different, right? Do you agree with that? The number in front of x is different. But all of these have the following in common.
I mean, they're like terms, right?
Sorry?
They're like terms, right? You could say it's like the numbers on the side.
Like terms. Well, they all have an x term.
Yes.
Yeah. Yeah. I think what I'm trying to say here is these are all linear graphs that go through the origin. And what I'm trying to say is all of these have a property that y is proportional to x. Because I can write y equals some number k times x. So here, k equals 2. Here, k equals 3. K equals 5. K.
Also, then when you get those like little box things,
Mm-hmm.
over that ball, you then go like whatever the x term times by that k.
That's right. So it's not so much that k is replacing the 1. It's more that it kind of is. Like, yeah.
It's like cancel the numbers. It's like you go over that.
No, because it's actually it's a good question, Maddie. I don't want to just brush it off. So I'm just going to spend a moment on this, okay?
Base spelled.
Hmm?
Base spelled. How do you spell it?
A little bit. Okay, so have a look up here. When y is proportional to 1 on x, I mean y equals kx. No, k divided by x, yeah? So can we read off the values of k here? So Maddie, I don't know if the purple helps. Every time I change the number on top, I'm getting a different value of k.
Yeah.
So what's the value here?
Is it just 1?
Yes. And what about this one?
And 2, 3, 5.
Yeah. So the point is, when I say this, I'm saying I know x is on the bottom. I don't necessarily know what number is on top.
And you don't change the bottom denominator, do you?
No. Unless I write a different letter here,
Yeah.
like T. Okay. I hope that helps.
Yeah. Thank you.
Okay. All right. Let's put some meat on the bone now with an example. Okay, so here's our first example with inverse proportionality. So, okay, so in this example, I'm going to start by telling you y equals 12 divided by x, and all I want you to do is complete the table. So there's no need to find k yet. I've told you the value of k. So this is like the first question in the exercise. So they give you a table of values, x and y. Do you remember the first time you did a table of values in maths?
No.
Okay, that's all right. I'm hoping it was quite early in school.
I was going to say, wouldn't it be like in primary school where you do like the plus? I felt like I did it when I was in primary school.
Oh, that's good. That's good. That's what we want.
Neither do I. I'm so bad. Are we copying the table down?
I know it's a lot of numbers, but we've got time, so
The answer is yes.
get it down. Yeah. It's easier than it looks. Okay, Mac, I'm going to ask you. So have a look up here. I want to work out this missing value here with the question mark in this table. And I've given you an equation to define the information in the table. Y equals 12 divided by x. So do you have any suggestions what we might do here? So, yes, when x equals 1, so I'm looking at this first point here, y equals 12 divided by 1, which is 12. Okay, so thank you, Mac. We have our first value in the table. All right, Kalisha, let's look at this one now. Any ideas? You want to pass? Okay, Tara? Okay, Jess?
That they should divide by 2 instead of 1.
That's right. So when x equals 2, y equals 12 divided by 2. So what I'm doing is I'm replacing the value of x here with the value provided in the table. Okay, 12 divided by 2 is 6. I'll fill in these for you. All right, let's go with you, Maddie, with your device there. I'm going to work out this one now. We need a slightly different approach. What do you suggest we do here? What do we know and what don't we know?
Sorry. So if each time is like divided by 12, then you gotta.
We're not quite dividing by 12. We're actually doing it the other way. We're taking 12 divided by the number x.
Oh.
Okay, that's what this means. This means 12 divided by x. Okay, so what I'm saying is 12 divided by some missing number x, I don't know what it is, gives me 0.25. And I want to work out that number.
48.
It is 48. Now, can you explain how you got that?
Because it's half from 0.5.
Great. Okay.
You also like, since you already got the y term, can you go 0.25 equals 12 over x and then use algebra?
Yes. So the way that I set this table up, it's possible to do what Maddie did and kind of work out the next value using the previous value. But if you can't do that, you need to use algebra. So I'll show you the algebraic way. When this time I'm given y. Y is 0.25. So this time I'm going to set up an equation involving x. Okay, I know y. It's 0.25. 0.25 equals 12 divided by x.
12 times 0.25 equals x.
No, not quite. Multiply both sides by x. That gives you 12. Then x equals 12 divided by 0.25. 0.25 is a quarter. If you divide by a quarter, it's the same as multiplying by 4. And that gives you 48, as Maddie said. Yeah, buddy. We'll do another example where we do the algebra thing. All right, let's finish off by finding this missing number here. I want to do the same thing as I did previously. So remember, I've given you the equation. Y equals 12 divided by x. So you don't actually need any knowledge of proportionality here. All I'm telling you is y equals 0.1. Tell me the value of x that gets me there. It is 120. Can you talk us through how you got there, Jess?
So y equals 0.1,
Mm-hmm.
and then it would go on 0.1 equals 12 over x,
Yep.
and then you would divide both sides by 2, which is 0.1 x equals 12,
Mm-hmm.
and then x equals 12 over 0.1, which is 100.
Great. Okay. I'm just looking around the room. I think I'm starting to lose some of you.
But can you like do one more table like that? Is that right?
Yeah, maybe they're all different values.
Sure. I'll have to think of one on the spot. So let's see.
And there's two different things that you've got to do.
Okay, so this time I'll give you a different formula. Let's say it's y equals 8 divided by x. And this time the values I'm going to give you are 1, 2, 10. And here I'll say 0.1 and 0.01.
So the first one's 8, the second one's 4, and then the one is 1.5. 1.25, sorry.
The third one's not 1.25.
And mine, 0.8.
Yes.
Sorry.
All right, I'll just quickly do the first three because I think you can. I think you can do the first three um, with some help.
I don't know how to do like the point.
It's the last three that I want to focus on.
So if y equals 0.1, so it's 0.1 equals 8 over x, and then you just go 0.8x equals 10. Sorry, no, 0.8x equals 8. What's my mind? No.
Okay.
0.8x
No. 0.1x equals 8.
Okay.
And then
It, yes. Now this is hard to do in your. Can you see that this is hard to do in your head?
yes.
Right? It took. See how many steps of algebra there were on the right hand side there. So I'm gonna try to explain this again, I ask that you try to follow. So in this part here, I know that y equals 8 on x. I gave you that formula. Okay? Here, I've given you y. I don't know the value of x. So to figure out x, I need to substitute the value of y I've been given and then solve the resulting equation for x. So I know y equals 0.1, so I'll replace y with 0.1. And that leaves me with 8 divided by x. This is your first step. You need to set up this equation. Okay? So if you can set up this equation, that's half the work done. The rest is just algebra. Okay? Now, I know I say just algebra. It's algebra that you can do with some practice. But I think the hardest part is actually just setting this up. Because you got to understand that you can substitute values into an equation and rearrange. Okay, so I can go over the algebra with you if you've forgotten. And you can use a calculator in this class. It's 80. All right, I'm going to do one last example, and then I'll let you get some work done. Was anyone still copying? No. Okay. Okay. Actually, before we do this, I'm so sorry. I didn't show you a picture. I need to show you a picture. All right. This is y. This is y is proportional to x. Does anyone know what y is proportional to 1 on x looks like? If you've done some physics or chemistry, you've probably seen it. What does it look like? So if I draw a picture, yeah, what does it look like? No, it's not a straight line. It's 1 on x.
It starts at 1, obviously. Then it goes to x.
All right, I'll draw it.
No. I can actually x.
Okay, so it looks like this. When x is really small, y is really large. And when x is really large, y is really small. Okay, so if you divide by a number smaller than 1, your answer gets bigger. If you divide by a number bigger than 1, your answer gets smaller. Okay, so here we've got the small x values, y is getting larger. Here, x is getting larger, so y is getting smaller. Okay, please do not leave here without that second picture taken down. So depending on where you go next, you may or may not see this behavior in what you're studying. My background is physics and maths, so I saw this all the time. But if you're not going down that path, most of your stuff will be direct proportionality. Okay, so back to this example. All right, can I change yet?
Yeah.
Thank you. All right, so um, this is something that I hope to give you on the test and on the exam. So because this is new, it might feel a bit difficult, but once you've done a few examples, I hope you will see that you just need to follow the same process each time. Okay, so you can follow a recipe to do this question. All right, so have a look at the question. I've given you two pieces of information. The first piece of information I've given you is this. What does that mean?
Y equals X over K over X.
Okay, that's our first piece of information.
I wonder if I could do this. Is it just 10 equals K over 2?
That's right. So the other piece of information I've given you is the coordinates. I've given you a pair of values in the table. So if I draw an imaginary table here, which you don't need to write, what I've actually given you is this. Okay, when x equals 2, y equals 10. So now what I want to do is figure out the constant of proportionality, or k. And as Ben mentioned, we know those numbers. We know that when y equals 10, k equals 2. Can we solve for k? What operation should we do? So this is
Shall
this.
multiply.
Yes. So this is way back from earlier in high school. To solve this equation, you want to get rid of the division by 2, so you do the opposites. The opposite of dividing by 2 is multiplying by 2.
So we're just trying to find K.
That's right.
Alright, so we're just doing 10 times 2 equals K, which is 20.
Okay. Do you want to do one more example of this?
So, yeah.
I know I said this was the last example, but if you want another one, I can do it for you.
I'd like to do that then.
Okay? Who's still writing? Anyone still writing?
Man, that's how I sing in the first place. That's why I sound like a husky man. Do I not sound husky?
Okay, I'm going to ask specific people. So I'm going to ask you, Ash. Okay, so you don't have to do the whole question, but I'll start by highlighting the important information. Yes. Okay, so let me break that down into two steps. First, we know that y equals k divided by t. Then we use these two values. 16 equals k divided by 4, just as you said. All right, AJ, what should we do next? All right, so I'm here. I want to solve for k. What operation should I do? to both. This is division. What's the opposite of division? Okay, so we divided by 4 here. So to reverse that, what number should we multiply by? That's it. Okay, multiply by 4.
Oh my gosh. Ready? 64.
All right, thank you for hanging in there. If you are having trouble following, I understand because this topic is a little bit abstract. So your priorities are to get your head around 9A first. Once you've got 9A done, then you can try 9B. Okay, we've covered 9B now, and we'll do 2 more next week, and then that'll be it for this topic. All right, so please get started on the exercises.